Hello, this is paper 2 of the 2018 TMUA. So 75 minutes, 20 questions. I think like the 2017 paper 2, I'll do it in 2 videos. So I'll do 10 questions here, 10 in the next video. Question 1, function f given for x is greater than 0 is this. Okay, so yeah, we've got square root on the denominator, so that's why x is greater than 0. Find f dash of 4. Right, so this thing then, I'll take the half out. X to the 5 over 2 minus 4x to the half. Differentiate this. So we still have the half there. 5 over 2x to the 3 over 2 minus 2x to the minus a half. And then put a 4 in. So I'll have a half. I'll have 5 over 2. So square root it, cube it, it'll be an 8. And then that's going to be a 2 over 2. Okay, so what's that then? I've got a half of 19, so C. Okay, question 2, find the value of the constant term in the expansion of this. Right, so we've got power 12 there, x6, we've got minus, so we're going to need what, 3 of those will make 18, 9 of those will make 18, so we've got an odd number of the minuses, so we are going to have a minus, so it's not going to be any of them. And then we're going to be doing, well, 3 in, so we'll have a 12 factorial over 3 factorial, not 10, 9 factorial. So what's that going to be? 12 times 11 times 10 over 3 times 2. So 4, 5, so 20 times 11 minus 220. Question 3. Consider the following statement. A car journey consists of 2 parts. First part, the average speed is u. Second part, the average speed is v. Hence, the average speed for the whole journey is a half u plus v. Well, only if they're travelling for the same amount of time at those 2 speeds. Which of the following examples provide counter examples? First part of the journey, we got 50 kilometers an hour for 100 kilometers and 40 kilometers per hour for 100 kilometers. Right, so that will be, because there's different amounts of time at 50 and 40. For part 2, we're doing 50 for an hour and 40 for an hour, so that won't be, because they're both doing an hour at each of the speeds. And then the last one, 50 for 80 and 40 for 100, which again will be different amounts of time. So it'd be 1 and 3. So F, right, pretty standard physics question, that one. 4, the non-zero real number c is such that the equation cos x equals c has 2 solutions going from 0 to 3 pi over 2. How many solutions does it have when we square it in the same range? Right, so we've got a cos x equals c. So we're doing that up to 3 pi over 2. We've got 2 solutions. So c's down here. We then we double it, we're doing a 2x here. So if we squared everything, then c, well, we know that c is less than, well, c squared is less than 1. C is between 0 and minus 1. So we'd have something, this would, okay, you get a bit of a flex on it, but it'll go like that. We'd have c going through there. So we'd have 3 solutions, and then we double the number of solutions because we're going to x, as in we're squishing everything. So we'd have 6 solutions, which is D. Okay. Question 5. 2 diagonals of quadrilateral Q are perpendicular. Consider the following statements. Which of these statements are necessarily true? So one of the diagonals is a line of symmetry, and the midpoints of the sides of Q are vertices of a square. So 2 diagonals of quadrilateral Q are perpendicular. So we've got some quadrilateral. Mistake usually of drawing these pictures is making them look too much like a square, but still so these are perpendicular to each other. So if they're perpendicular, then what do we have? The midpoints of the sides of Q are the vertices of a square. One of the diagonals is a line of symmetry. Well, no, that can't be right. I mean, we could take this corner and we could move this in and out, and it wouldn't affect the fact that the diagonals are perpendicular. So we could move it down here, in which case we could do the same with this one, with the line of symmetry. Yeah, I mean, moving one corner in or outwards is definitely going to make part 2 not necessary, because yeah, there's no way that's going to keep it as a square. You know, if we had something looking like that and then you join up the midpoints, then actually, I don't know, let's draw this out again. So if I had something really wonky, so let's have 2 of them that are sort of close, and then these ones which are like this. So let's draw something really wonky. So something like that. These are still perpendicular to each other. Neither of them are lines of symmetry, so it's definitely not 1. And then if we add that and that and that and that, well, that ain't going to be a square. So it's not going to be 2 either. So it's going to be A, because yeah, you can just squish these things in so much that we can reduce the width of the sides. Yeah, reduce one dimension and increase the other. So it wouldn't have to be a square for the midpoints. Okay, that was a bit more involved. 6. Which one of the following functions provides a counterexample to the statement if f dash of x is greater than 0 for all real x, then f of x is greater than 0 for all real x? So first of all, we need something which satisfies that. F dash of 0 is f dash of x, is greater than 0 for all real x. So, well, not A, not B, not D. Oh no, D. D could be. But then it doesn't satisfy the second part. Yeah. So for D, f dash of x is 1. So that's fine. But f of x isn't always greater than 0. Right, okay, so I can rule those out. E is just going to be, well, it is going to be an example of when that is true. So it's going to have to be C, isn't it? It's going to have to be C, because we've got 3x squared plus 1. So that satisfies the first part. But we can make this negative. So yeah, definitely C. Okay. Question 7. Sequence 1 is an arithmetic progression. First term 11, common difference 3. Sequence 2, first term 2, common difference 5. Some numbers that appear in sequence 1 also appear in sequence 2. Let n be the 20th such number. All right, okay, let's look at the sequences then. So we've got 11, 14, 17, 20, 23, 26, 29. I'll write a few of them out because these are going to hit every 3 or 5 depending on which one we're looking at in it. So I've put quite a few down. And then 2, 7, 12, 17, 22, 27, 32. There's our hits, 17 and 32. So every third one there, every fifth one there. So the first hit is at 17. And then we want to have the 20th number, and it's every 15. So we want to do 19 times 15. So that's going to be what, 302, because it's going to be 20 15s plus 2. And then we divide them by what? Divide by 7. So if we divide by 7, we have 280, and then another 21 will take us 301, so we'd have remainder 1, which is B. Cool. Question 8. Diagram shows an example of a mountain profile. Upstroke, downstroke, upstrokes which go upwards from left to right. Downstrokes go downwards from left to right. 6 up, 6 downs. Horizontal line at the bottom is sea level, fair enough. Mountain profile of order n consists of n upstrokes and n downstrokes, with the condition that profile begins and ends at sea level, never goes below sea level, although it might reach sea level at any point, as it does here for that bit. The example shown is mountain profile of order 6, so 6 up, 6 down. Okay, mountain profiles can be coded using U's for ups, D's for downs. Fine. Sequence of U's and D's obtained from a mountain profile in this way is known as a valid code. Which of the following is true? Valid code is written in reverse order. The result is always a valid code. Well, no, because you're going to end on a down. So if you do it backwards, you're going to start by going down and go below sea level. If each U in a valid code is replaced by a D and D by a U, the result is a valid code. Same problem. You'll start with a D and you can't start with a D. If U is added to the beginning of a valid code and a D at the end, then the result is always a valid code. Well, yeah, it would be. You get a profile and you add an up at the start and a down at the end, you don't have any problem. So it's going to be just 3, which is D. That was a lot of reading for what was a fairly simple question. Consider the following attempt to solve this equation. Okay, all of that. The solutions of the original equation are those. Which of the following one is correct? So only one of those is correct, or there's another value that's correct, and where is the error? So 5/8 and 5/2. Let's see if these work. So it's 5/8, 5/2. So if we add 5/8, we'd have 5/2 times the root of 5/4 minus 1. So that gives me 5/4, doesn't it? Because that's the root of a quarter. And then that would be equal to 50/8 minus 5. So that's 6 1/4 minus 5 is 1 1/4. So that one works. 5/2 will give 10 times the square root of 4. So 20 equals 25 minus 5. So that one works as well, right? So they're both correct. So it's definitely not those ones. Is there another value? That's going to be the other thing. Let's look at these steps then. So what have they done first of all? They've just factorized, so that's fine. Then they have squared, so that's fine. Then they, oh, here we go, they divided by 2x minus 1. So they've thrown out x is a half as a solution on that, because yeah, if we get x is a half, we've got 2 times 0 is equal to 5 minus 5, right? So there we go. So we've got, what is it? There is another, what's the step that went wrong? Step 3. So that is f. Okay. Function f of x is defined for all real numbers. Consider the following 3 conditions where a is a real constant. Okay, we've got various transformations. Which of these conditions are necessary and sufficient for the graph y equals f of x to have reflection symmetry in the line x equals a? Okay, right, this looks tricky. I mean, do I want to try and think these through just in terms of transformations? That doesn't sound like it'd be much fun. And there's, oh, it's just all permutations that we've got there. So I think a sketch might be the way to go on this and try and pick apart the different positions of all of these points. So say we add, so let's draw out some axes, put in our line of symmetry at A. I mean, A could be anywhere, but it just helps to not have it at 0, doesn't it? To see a more general case, I think, of visualizing it. And we want anything here which is then symmetrical reflected about that line. So, well, parabolas are easy enough to draw in, and something which is symmetrical with reflective symmetry. I mean, it doesn't have to be, but yeah, it's just easy to draw, isn't it? So we've got that, and then we've got all of these different positions. We've got an a minus x, an a plus x, x's. So let's build up these points down in here. So say I put, I don't know, x here. So that would give me an f of x at that point. Okay, and then we want an f of a minus x and an f of a plus x. So, well, let's put a minus x in. So minus x would be over here. So if I was doing a minus x and compare it to a plus x, right, so a plus x is then up, say, here, a plus x. So a plus x is obviously x up from a. So when I do a minus x, I want to end up being x down from a. So what am I at the moment? So going from a down to minus x is a plus x down. And then we go a up will mean that a minus x is going to be x down. Right, okay, so if I put a, which is be, yeah, that'd be right, wouldn't it? A minus x. A minus x is a up from x. Yeah, so that works fine. So we've got, this is going to be x down. from A. So I definitely got that right. So A plus X is X up from A. A minus X is X down from A. Yeah, that makes sense. Actually, I don't think I needed to draw all that out. Just saying that in the way, if you're going from A and you add X, you're going X up. If you take X off, you're going X down. So either way, we're the same distance away from A. So yeah, that one's got to work. So I'm happy with that one. The 2A minus X and f of X. So I can do the same thing. So X is going to be, so the difference here of X from A is X minus A. That's that distance up. Then for 2A minus X, so we're now going, we start off at minus X, which is X plus A down. And then we go 2 lots of A upwards. So that'll take it up to X down and then X minus A down. So we've got X minus A up and X minus A down. Right, so that works as well. Okay, that's good. F of A minus X, I mean, that can't work. I mean, we've had that in the first one. So if the first one works, the third one can't work because they contradict each other by the look of it. So yeah, so that definitely can't work because you've got one of them is X minus A up and the other one's X down. So it can't be that one. So it must be 1 and 2. 1 and 2, which is B. Okay, that was a sneaky one, that one. There might have been a way of just doing it in terms of transformations and things, but it can get a bit fiddly when you're doing multiple transformations. So you're doing a translation and a reflection on some of these things. So yeah, looking at these variations, these distances away from the line of symmetry, I don't know. It seemed like the way to go anyway. But still, that's the first 10 questions. As I say, I could probably do another 10, but you might get some long ones on a paper too. So I think splitting it in 2 videos probably makes sense. So I'll leave it here for this, and then I'll be back for another one soon.